there, welcome back to ExamPadi. Our topic today is simple equations. In this lesson, we will 1. Explore simple equations and learn how to formulate equations. 2. Explain how to translate algebraic equations into word sentences and vice versa. 3. Solve simple equations using different examples. A simple equation is a mathematical statement that represents the relationship between two expressions on either side of an equal sign. In summary, simple equations are straightforward to solve and typically involve one variable. They are a fundamental part of algebra used to find the variable's value that makes the equation true. While algebraic expressions are the building blocks, simple equations involve the equality of two of such expressions. Imagine you have a box with a mystery number of coins inside. If you add 3 more candies to the box, you will have 7 coins in total. To find how many candies are in the box right now, we can use a simple equation. We often use a letter to represent the mystery number, which is x in mathematics. So, if x is the number of candies in the box, and I add 3 to it, I get 7. We can write this situation as an equation, that is, x plus 3 equals 7. To determine the number of coins in the box, or what x is, we do the opposite of adding 3 and subtracting 3 from both sides of the equation. This is what it looks like. X plus 3 minus 3 equals 7 minus 3. When we simplify that, we get x equals 4. So there are 4 coins in the box. Let's take a look at a few examples. If a number is multiplied by 4, the answer is 6 more than the number. Write an equation to represent this. Solution. Step 1. Identify the unknown and make it x. In this case, the unknown is the number, so we say the number is x. Step 2. Write an expression or value for one part of the equation. One of the phrases states that the number is multiplied by 4. We write this as 4 times x, which equals 4x. Step 3. Write an expression or value for the other part of the equation. Another phrase refers to 6 more than the number. We write this as x plus 6. It means we are adding an unknown to the number, which is 6. Step 4. Remember that an equation has equal sign, which decides how the two expressions are equal. The word says the answer of the multiplication by 4 gives the addition of 6. Therefore, 4x equals x plus 6. Example 2. A mother is twice as old as her daughter. In 2 years, their combined age will be 52. Write an equation to represent this. Solution. Step 1. Identify the unknowns. There are 2 unknowns, the mother's age and the daughter's age. Step 2. Make the unknown x. Write an expression for the other unknown in terms of x. Make the daughter's age x. The mother's age is twice that. Therefore, the mother's age is 2 times x, which equals 2x. Step 3. Write an expression or value for one part of the equation. One phrase refers to their ages in 2 years. Therefore, the daughter will be x plus 2 years old, while the mother will be 2x plus 2 years old. Step 4. Write an expression or value for the other part of the equation. Another phrase says their combined ages will be 52. Step 5. Remember that an equation has an equal sign. This decides how the two expressions are equal to each other. Their combined ages in 2 years equals to 52. If we combine their ages, this means we add the ages. Therefore, x plus 2 in brackets plus 2x plus 2 in brackets equals 52. Let's take a look at further examples. Translate the following statements into mathematical algebraic equations. 1. Olu thinks of a number and 3 is added to it. With the result of 8, what is the number? Solution. Let the number be x. X plus 3 equals 8. Subtract 3 from each side. X plus 3 minus 3 equals 8 minus 3. X equals 5. Definitely the number Olu is thinking of is 5. 2. The sum of two consecutive odd numbers is 32. Find the value of the numbers. Solution. Let the smaller odd number be x. The next odd number equals x plus 2. The sum of the two odd numbers is x plus 2. Given condition states that x plus 2 equals 32. That is, the sum of the two odd numbers equals 32. Adding x in two places, that is x plus x, gives 2x plus 2 equals 32. Collecting like terms, we have 2x equals 32 minus 2. 2x equals 30. Dividing both sides by the coefficient of x, which is 2. X equals 30 divided by 2. X equals 15. Therefore, the two odd numbers are 15 and 17. Translation of algebraic equations into word sentences. We can also translate algebraic equations into word sentences. You can make up a story if you want to, or think of the variable as a number. Translate the following equation into a word sentence. 3 plus y equals 10 minus 2y. Step 1. Assume that the variable is a number. In this case, the variable is y, so we will assume that y is a number. Step 2. Interpret one part of the equation. 3 plus y means we add a number to 3. Step 3. Interpret the other part of the equation. 10 minus 2y means we subtracted twice the number from 10. We can also say it is the difference between 10 and twice the number. Step 4. Say how the two parts are equal to each other. When we add 3 to a number, the answer is equal to the difference between 10 and twice the number. Let's take a look at how to solve equations. After we have learned how to find the values that make open sentences true, look at the following algebraic equation. 3 plus x equals 5. It is easy to see that the only value for x that will make this equation true is 2. This is because 3 plus 2 equals 5. We say the number 2 is the solution of the equation, and we write it as x equals 2. When finding the solution of an equation, we say we solve the equation. To solve an equation, we must isolate the variable. If x is the variable, we must get the equation in the form x equals value. For example, x equals 2. Let's take a look at a few examples. 1. Solve the following equation. 2x plus x minus 10 equals 2. Step 1. If either side of the equation can be simplified, do that first. On the left side, you can add like terms, that is, collect like terms, and then you add. Therefore, we have 2x plus x minus 10 equals 2. 2x plus x equals 3x, and that will give us 3x minus 10 equals 2. Step 2. If a constant term is on the same side as the variable, add its additive inverse. Remember to do this on both sides of the equation. What this simply means is you are adding the opposite of what we have on both sides. That is, we have 3x minus 10 plus 10 equals 2 plus 10. It's just the same thing as saying collecting like terms. So we have 3x equals 12. Minus 10 plus 10 is 0. 2 plus 10 is 12. Therefore, we are left with 3x equals 12. Step 3. If the variable has a coefficient, divide both sides by the coefficient of the unknown. Remember to do this on both sides of the equation. We have 3x equals 12. We are dividing both sides by the coefficient of the unknown, which is 3. 3x over 3 equals 12 over 3. 3 will cancel 3. 12 divided by 3 is 4. Therefore, x equals 4. Let's check if our workings are correct. 2x plus x minus 10 equals 2. To do this, we substitute the answer we got, which is 4 for x. That is, wherever we find x, we replace it with 4. 2 into the bracket of 4 plus 4 minus 10 equals 2. 2 multiplied by 4 is 8, plus 4 minus 10 equals 2. 8 plus 4, 12. 12 minus 10 equals 2. 2 equals 2. Definitely, the left-hand side equals the right-hand side. Note that when checking, your left-hand side must be equal to your right-hand side. That is, LHS equals RHS. 2. Solve the equation 18 minus 5x equals 4x. Step 1. Use the additive inverse of a term with a variable to add or subtract it from both sides. We will start on the left-hand side. What this simply means is collect like terms. That is, the number carrying the variable should go to meet the number carrying the variable at the right-hand side. Here we have 18 minus 5x plus 5x equals 4x plus 5x. Minus 5x plus 5x will give us 0. Therefore, we are left with 18 equals 4x plus 5x, which is 18 equals 9x. When we are in this situation, we are expected to divide both sides by the coefficient of x, which is 9. Therefore, we have 18 divided by 9 equals 9x divided by 9. 9 in 18 is 2. 9 in 9, 1. 1 times x is x. Therefore, x equals 2. Example 3. X plus 8 equals 12. The unknown x is on the left-hand side. Since 8 is added to x on the left-hand side, we subtract 8 from both sides. The reason why we are subtracting 8 from both sides is because we are having the opposite of minus 8, which is plus 8. X plus 8 minus 8 equals 12 minus 8. 8 minus 8 will give us 0. 12 minus 8 gives us 4. We are left with x plus 0 equals 4. Therefore, x equals 4. Example 4. 72 equals 9x. This is very simple. The unknown x is on the right-hand side. Since x is multiplying x on the right-hand side, we divide both sides by 9. 72 divided by 9 equals 9x divided by 9. 9 in 9, 1. 72 divided by 9 is 8. Therefore, x equals 8. Example 5. X over 2 equals 5. Since x is divided by 2 on the left-hand side, then we multiply both sides by 2. Or we can say we cross-multiply. X over 2 times 2 equals 5 times 2. 2 cancel 2. We are left with x equals 5 multiplied by 2. X equals 10. We can then say x over 2 equals 5 gives 10. We have come to the end of today's lesson. Here are a few questions to assess yourself. 1. Write an algebraic equation for each of these situations. A. If we add 23 to a number, the answer is 42. B. The difference between 75 and a number is 20. 2. Write a word sentence for each of the following algebraic equations. A. X plus 12 equals 25. B. 2y minus 8 equals 30. 3. Solve each of the following equations and check the solutions. A. 11x equals 33. B. 18 plus p equals 6. 4. Translate the following word sentences into mathematical statements. A. 1/3 of a number is subtracted from half, and the result is 1. Find the number. B. 5 is added to a number, and the result is 9. Thank you for learning about simple equation with me. I hope you'll be practicing more questions on simple equation. See you in our next video. Bye.